All right, welcome back, everybody. We're going to get started. This is Power Programming 2, subtitle Effective Debugging. We got a lot of great stuff to go over for you. We're going to probably move a little bit quick. There will be time for questions at the end, so if you think of anything, save that. We're also going to try to have a little fun with it. So here we go. My name is Jeff. I am a full-time CIQ app developer here at Garmin.
And I'm Adam. I work on software for the Vivo Active watches, but I've had a CIQ internship and have been doing full-time CIQ work for the past few months.
All right, so moving right into it. Bugs. Who here, show of hands, has ever written a bug? Has anybody not written a bug? Never written a bug? Okay, well, I think we got another breakout session around the corner. That might be more useful. Just kidding. We all make mistakes. It happens. You're going to write bugs. The important part is what you do next. Even Thomas Edison said, I haven't failed. I've just found 10,000 ways that won't work. 10,000 is a lot of bugs. He probably could have used a better debugger. And we're going to give you all the tips and tricks you need to write way less bugs, and if you do write bugs, fix them quickly and efficiently. So, help. I wrote a bug. This is Kansas. We're in the land of Oz, and so come with me on my metaphorical journey down the yellow brick road of code developing. You might run into crashes and failures and leaks. Oh my! But much like Dorothy, who learned that she didn't have to be afraid of lions and tigers and bears, you don't have to be afraid of making mistakes writing bugs. And if you like The Wizard of Oz, we have a great themed marathon this Saturday. Anybody going to that? All right, excellent. So after you've identified your bug, your crashes, your leaks, whatever, and we will give you the tools to identify them, the next thing you need to do is investigate why they happened. And we will help you with that as well and give you everything you need to know to then fix it. So we're going to go through a few debugging strategies. The first is, oops, I wrote a bug, something went wrong, and you figure it out after the fact. This is post-mortem debugging. Maybe you're viewing a crash log while developing. Maybe you have an SQ phase, software quality phase, and your testers write some issue tickets for you to fix. Maybe you've already released your app, put it on the store, and you get a bunch of one-star reviews with something really helpful like, this doesn't work. What do you do next? So with that limited information, maybe not a lot. The next step is printf debugging. This is really helpful during development. We all know printf debugging. This is basically just putting simple logs into your code. Every time you do this, you have to add another log statement. You have to recompile. It's time consuming. And if you're like me, sometimes you're like, I have no clue what line failed. You just start adding logs all over the place, and then your console is just spammed with nonsense. And when you finally do find the bug, you then have to go through and remove all of it. So maybe not that helpful. The better way to do it is using a remote debugger. This allows you to get a live inspection of what is going on with your app, and we'll show you several tools that allow live inspection of the state of your app as you're developing it. Remote debugging is way less cluttered because all you have to do is put breakpoints in a debugger, so you're not spamming your console with a bunch of extra information. You can see just the information you want when you want it. It's on demand when you want it and not when you don't want it. So you can run a debug during development, and then when you're more in testing, just run in release mode. So printf can still be useful in some cases. I know I just was a little harsh on it, but let's see how we can make the most of system print. In a monkey see world, we have the system module print line, and what I like to do is move that long call that requires us to import the system module into all the files that we want to log into a global function. That way I can have a single use of system and maybe shorten the name of the logging function to something easier to type And it looks like this. If you put it in the global space, as Shannon mentioned in the previous presentation, you want to reference it using that $sign to improve lookup speed. We can have our log, have the VM look immediately at the global functions for where our global log function is. Well, say we want to leave some of these logs in our code, but we don't really want to release them to our users. We can use jungles, which you've probably also learned about. You get 2 free default jungles without having to do any extra work. Those are debug and release. So in this example here, I have logging statements in debug mode, but in release, this function just does nothing. So you don't waste any extra code space. It's just gone, and when your app is on the store, it's not putting out a bunch of verbose logs. But we can make this even better. I like to think of my log function like a little bit of coffee. Some people like a little bit of sugar. Some people like a lot of bit of sugar. So we can add parameters to our logging. Say we want to add a severity parameter up here. And that way we can output different tags on our log statements in console, so maybe they're more important to us. Maybe you want to go a step further and you want to add timestamps. Pretty useful. And now you have all this stuff in your logging function, and you can download an Eclipse plugin that lets you syntax highlight your console output, and you might get something like this. So we might have a lot of spam, but if some fatal case happens, you're really going to notice that. So now you got this really advanced logging function that you can use everywhere, and you think, well, I want all my apps to use it. I want to share it. Well, sharing is caring, and as we learned earlier, sharing is barrels. And you might be thinking, wait, hold on a sec, Jeff. I came to this presentation last year, and did you guys already write this? And yes, we did write this for you, and we have a barrels on our Garmin GitHub. If you look in barrels, it's called LogMonkey, and it has severity, it has tagging, it is in a barrel, it's in a global module, so you can reference it directly. And if you use Eclipse, I know not everybody's favorite IDE is Eclipse, but if you do use Eclipse, there's a tab down by your console called Monkey C, like S-E-E, Monkey C, that is integrated with LogMonkey. It'll let you filter based on severity, it'll let you filter based on tag, or the app you're running, and you can actually, I think, filter on anything you type in. So it's way more helpful, and it gets around the problem of log spam. However, you're still adding a bunch of logs into your code. So let's go through better ways to debug without having to change code. So we have several debugging tools available for you. Most of these are when utilizing the simulator and won't actually attach to a device. But we'll go through the Eclipse debugger, storage editor, web traffic viewer, memory viewer, monkey graph, and my favorite, time machine. Who doesn't like time travel? All right, so let's just get right into it. The Eclipse debugger. The Eclipse debugger is just like the Eclipse debugger for any other language. Pretty simple. For those who aren't familiar, we're just going to go through some quick examples of how to use that. So say we get a crash while developing, and we get some stack trace here, unexpected type on this line. Well, we can slap a breakpoint on that line. Also, come on a journey with me where I make up random code for demo purposes that I won't actually ever write. So if this doesn't make sense, it's just for the demo. So we hit that little bug icon next to our normal play icon. I believe F11 is the hotkey in Eclipse. And we hit our breakpoint, and we look in our variables tab, and my object is null. Of course, null is going to crash when we try to call something on it. So, well, okay, that's not super helpful. We probably just ended up putting our breakpoint on the wrong line. So my object got set a line earlier, so let's put our breakpoint there instead, and right here, and we will use the step in button here, step into our function, and step over through it until we see we knew return is going to be null from our previous example. And we look at our variables tab again, and aha, A equals B is going to return false because one's a number and one's a string, and those are not going to be equal. Okay, so moving along, how can we fix this? Maybe we decided that this function always has to return an object. I mean, it makes sense. It's called getSomeObject. We could add, this is a great place to add in our fancy logging from earlier, log severity right here, or you can put in logmonkey and give it the maximum severity. And what I like to do is then in my global logging function, just permanently put a breakpoint on the fatal case and always run in debug mode. So when I hit that, if something fails and I get to this point, the bug will just stop for me. Keep in mind, for those not familiar with the debugger, if you stop in a function, the variables tab will give you global scope and your local scope. However, you can move up the call hierarchy with this little side tab. So right here, my global log function is an app, but my crash was in my view. So I can click on that view, and then I will get the local variables for that view. That was the previous screen I showed with A and B not being equal. All right, so moving on. A few extra points, just things you can do with the debugger. There's a tab that lists all of your breakpoints. So maybe going back to hey, I put printf between every single line. Well, instead, put a breakpoint on every single line, or every place where you think there could be a failure. Maybe you end up with a ton of breakpoints through several iterations of your development. You can go to this tab and disable breakpoints. Pretty straightforward. Another thing I want to mention is viewing viewing structures in the memory or the variables tab here. So here's an example of an array and a dictionary, what those would look like. I'm showing this mostly because you've all read the documentation, of course, and you came across the part that said dictionaries are not guaranteed to be stored in the order in which you added them. Here's a great example. This is ABC. It's just random. That's up to the VM at runtime. So maybe you ran into an error where you thought those were in the same order. You were trying to iterate through a dictionary for some reason, and you can step in here, hit a breakpoint in your debugger and see, oh, okay, that's not the case. Well, Jeff, what if my problem isn't in some memory, it's in something I've saved to the device? Well, we have something for that too. It is our storage viewer. In the simulator, hotkey Control S, you can open up the storage editor, which will show you a key value pair of everything that you've saved using the storage, the device storage. So on the left, we have keys, and on the right, we have values. This will show you built-in types. It'll actually show you images as well, and it allows you to actually edit the values in storage. So all these white fields are editable. Arrays and dictionaries are not editable in the storage editor. One caveat is that if you change something and press OK, it's going to restart the app. However, this can still be useful for several reasons. A, you can find unexpected data. Hey, I don't remember saving that. Or, hey, I thought I was saving A and I saved B. It allows you to do some quick development level testing. So maybe instead of writing a test button that you press to fill in a bunch of data, once you have the keys established, you can change this all and do several runs. This will let you test edge cases. Maybe some real world sensor is generating data that's getting stored and you don't know how to make it not work. Well, you can just come into the storage editor and break the data and make sure your app appropriately responds to that. And last but not least, you can find orphan data. So maybe over multiple iterations of your development, you changed keys, but you never cleared out your memory, and you're like, why do I have a huge chunk of storage for this app? Well, you can see all the keys that you left behind in previous development.
So what if what you have in storage is not actually the cause of the problem? What if you got your storage based on a web request? Well, we also have a tool for that too, and that's the web traffic viewer. Hotkey Control-H while you're running the simulator, and when you do that, you get a window that looks like this. Now, that's a lot of text and really small. I'm sure you can't really read it, so we'll take a look at the left half first. So this just gives you a couple statistics up top over all your web traffic, broken down by whether it's an upload versus download, body versus header, just some really overall useful stuff. And then below that, you've got your history of all your web traffic. It's got the direction for whether this is outgoing or incoming. It's got a timestamp for when you made it and a preview of the content over on the right side. So if you do select a line, though, on the right side of that big window, you have the content pane, which shows you the content in both plain text and binary. Now, this is super helpful for a few reasons. So if you say in your web request you're expecting, say, JSON back, but say you had bad creds and your server barfed on you and gave you a 403 HTTP page. Well, HTTP is XML, which isn't JSON, so you're going to get a negative 400 back to your widget instead of the actual return code because you have a malformed body. But this traffic viewer will let you actually see that XML that you got back instead of just a negative 401 with no explanation for what went wrong. It also lets you debug faster because if you do notice that something went wrong, you can just open up the traffic viewer because it stores your whole history. You can just look through, see what went wrong, and examine the data. Maybe the server has a bug, maybe it's your widget, who knows, but it does definitely help instead of just having to add extra logging back to your app, having to rerun, try to reproduce that scenario. You can just open up the history and everything's good. But speaking of web requests, now that we have LTE capability, there are some things regarding that you should be aware of. So first off, your app, the device is either connected to the phone or it is connected over LTE. It's not going to be both. And so when you are connected over LTE, you're going to want to try and reduce your data that you send. First off, because LTE is a major battery drain. Just being on drains a lot of battery, but actually sending lots of data over LTE will drain your battery as well. I made a mistake while working on the VivoActive 3M LTE and accidentally made a web request every few seconds. And if you do that, you'll drain the device in about an hour, and the device will physically get warm. So you don't want to do that. Plus, your customers are paying for the data. You don't want to eat it all up. And so you can check what's on, whether you're on LTE or Bluetooth, via the device setting connection info data variable. And if you just want to check generic internet connection, you've got the device settings connection available that you can check. And the last point is that if you try to make an OAuth request, you're still going to need to be connected to the phone. That won't work over LTE, and that's because the phone is what the user uses to sign in. So they can't sign in over LTE because we don't have that capability on the devices. So moving right along, our next tool is the memory viewer. And you can access that again in the simulator, hotkey Control-M this time. And when you do, you will get a window that looks like this. So up at the top, you've got statistics about your memory usage, your peak memory usage. It'll help you see if you're over the limits or not for some devices. Say you're running on a device that has 65K available for a widget, and there's another device that has less than that, and you see if you're over or not. If you are over, you can get in Eclipse, if you try to run in the simulator, you can get a error, failed to load application, and that means you're over your memory limit for that device. And then down at the bottom, we've got a breakdown of all your memory and what is using how much in your program. So this is useful for A, seeing if you're over in your memory, and B, circular references. So, why are circular references an issue? Well, Monkey C uses automatic reference counting for its memory management. And so if you have two objects that reference each other, and even if all the other references go away, their reference counts never go to 0, and so they stick around forever, and they're lost, and you can't get them back. But in the storage viewer, or memory viewer, excuse me, if you open that up, you can see that you get circular reference if you have a circular reference. Here we've got object 1 that has a pointer that references object 2, and object 2 has a pointer that references object 1. So they're pointing to each other. And now there is a caveat to this. You can only see this in the memory viewer if you have an outside reference to at least one of those objects in the cycle. Because the memory viewer looks at what's in your, what's accessible from other objects in your app. So if nothing's accessible from anywhere else in your app, it's not going to be able to find it. So it only really shows you what has potentially, what has the ability to potentially leak in the future with the circular reference, not what actually has been leaked. And so if you already have a leak and you know you have a leak, really the only way to see that is that your memory usage just continually increases as you do the same action over and over and over. So in addition to finding circular references, which fixing leaking memory will help you save memory, there are more ways to save memory that'll have a greater impact that you'll probably run into more often. The first of, so why do we even need to worry about memory at all and saving memory? Well, we have very limited memory on our devices. They're just embedded devices. Data fields only have 16K, widgets at the lowest end have 64K, and background processing only has 32K. And so one way to save a lot of memory is to reduce the data that you're using. If you, let's say we have this, we've got one field up here, my time, and it's being set to a moment object. Now, if we open up the memory viewer, we can see that the my time object takes 108 bytes. Now, if you just need something that represents now, you don't need the full power of a moment object and all the utility functions that come with it or whatever. 108 bytes sounds like a lot. And so if we update it to use the dot value, which will return just a timestamp, which is an integer, instead of the full moment object, and then we open up the storage viewer, we can see that my time looks like it's apparently free. It's not taking any memory. Well, that's not really true, because in the previous case, view had a reference which took a few bytes to my time, and that reference got replaced with the actual integer value. So the memory for my time is actually in the view, although it's a little hidden. So what do we learn from this? Well, objects are expensive. Most of your objects are always going to be greater than 100 bytes. So if you can get away without using an object, like in this example, using a timestamp instead of a moment, that's usually pretty worth it. And it'll say it can add up quickly. Also, if you are using dictionaries or arrays or storage, you can use integer keys in those. And if you do, there is a trade-off for storage, because if you do print out and dictionaries, if you do open up the storage viewer, say, or print out your dictionary, instead of if you used a string, if you would have used a string for your key, but now we're using an integer, well, you saved all the bytes from not using a string, but it's a lot harder to read because now you've just got like 1 points to 2, and nobody can read that very easily. But if you do have integer keys and you're using a dictionary and they start at 0 and they increment, well, that's what an array is for. You can swap out a dictionary for array, you'll save even more memory there. And then with JSON data resources, so if you are, say you're making a web request and you have a lot of relatively long strings in your, say, JSON payload that you're uploading, then if you made them all constants, then they'd stick around for the whole lifetime of your app, and they'd be hogging memory that whole time. But if you put them in a JSON data resource, then you can load them when you need them with a load resource call. And then when you're done with them, assuming you don't have circular references, the memory manager will clean it all up for you, and you'll be back to a lower memory state. Now keep in mind, all these aren't for saying, hey, you need to get under 65K and you're at 120K. They're not going to get you down there. These are for, these tips and tricks we're showing are for if you're, say, at 70 and you need to get under to 65K. It's like right barely on the limit, and you need to just that little bit more to get you under. So that's saving your data that you're using at runtime. Well, there's another place you can save memory, and that's in your code space. So your code space counts towards your memory limit whenever you're running. And so one of the heavy hitters here are classes and modules. And that's because they need to store type information for lookup at runtime. And the reason for this is because Monkey C is a duck-typed language, it needs to know what the types are at runtime so it can figure out what the appropriate action is when you say call a function on an object, like where does it start looking? What class does it look for that function in? And another thing that has the same type information are enums and constants. So if you have an enum that has, say, is assigned the value of 5, well, it's not just going to be replaced in your code wherever and you get it for free. It's going to have some type information associated with it. So one way around enums and constants are if you have integers for your values, you can use symbols. And those are the colon with your identifier afterwards. And the only caveat there is you can only use symbols to replace your integer constants if you don't care about the value. Because as you change your program, those symbols will change their values. So you don't want to use it for something like storage keys, where you could release an app with your symbol having a value of 5, and then in the next iteration it's a value of 6. You didn't know it changed. And that would be a great place to use the storage viewer to see what went wrong. This one's kind of controversial, but if you really, really need to save memory, you can not specify the modules. So what do I mean by that? Well, as Jeff said, and as you heard in the last presentation, when you call a global function, you can specify the $ with the dot. Now that's what I mean by the specifying the module. That specifies the global module. If you have your own custom module, you can specify like my module dot my cool function or whatever. If you do not specify a module, then you can save a couple bytes. Now there is a hit there with the VM has to do extra looking up to see what that function actually is. If it's, say, a global function, it has to go through all the current module functions and object functions and all that stuff. So there is a hit, but it is a place where you can potentially save memory if you really, really need it. And another way to get this for sort of free is to use the using keyword. So if you were saying toybox.system.println, up at the top you can say using toybox.system, and then you can say system.println, so you get that toybox.specifier for free, essentially. So yeah, just to give you all a couple of numbers of how this actually affects you. So defining your class, just an empty class, you don't even have to have anything in it. It'll take 77 bytes for all its type information and whatnot. A module, 48 bytes, and then, so if you can, say you have a class that only has static stuff in it, if you can convert that over to being a module instead of a class, you'll save a few bytes there. So it's little things like that. If you simply define an enum value, don't actually use it anywhere, just define it, that'll cost 8 bytes, and then every time you use it, that'll cost 3 bytes. So it might seem like a little bit, but it can add up over the course of your whole program, especially something like a widget that might be run upwards of 65K. If you use these, say, 100 times, it can definitely add up. And the last one, specifying a module, it's 6 bytes. So it's not a big gain, but if you really, really need that memory, this is how you can get it. So taking a look at what happens if you don't specify a module, going into a more in-depth approach at it. So up here, we've got our global function, and that's what we're going to try and call. So the first thing we have is our bar module, and bar module has a class called bar in it. Then down here, we've got foo module, and that has a class called foo. So what we're going to do is create a foo object and then call foo2, which calls a global function. So what happens if because this doesn't have the $ global module specifier on it, what does the VM actually do? Well, first the VM is going to look through all of the instance methods for that object up the hierarchy of classes. So first thing it's going to look at is foo2. Well, foo2 isn't global func, so it's going to keep going. So we're done with foo. We need to go up to bar, the superclass of foo. And so it's going to take a look at bar2, the instance function of bar. But that's not global func, so we got to keep looking. So now that we've exhausted all of the instance methods, we're going to take a look at the static functions, again, up the class hierarchy. So first, we're going to take a look at foo1, that's the static function. That's not global func, so we got to keep going. So we go up to bar, and we see bar1. Well, bar1 isn't global func, so again, we got to keep going. But we've exhausted all the static functions, so now the VM is going to look at the module level functions in the modules that contain your class all the way up the hierarchy. So at this point, it'll take a look at the foo modules, foo module func, because foo module contains foo. And that's also not global func, so we got to keep going. So it'll go up the hierarchy again to bar module, and it'll see bar module func. Well, that's also not global func. And so now that we've exhausted all the module functions, we can finally start looking at the global functions, and that's when we find global func. So there is a lot more work for the VM if you don't specify the module, but the time penalty isn't that big. On a vivoactive 3M, I did a test, and I think I had 50 functions that I had to look up through, and it added maybe a millisecond to my total call time. But that's just for one call. If you're calling these a whole lot, there's going to be the penalty adds up really quickly. So just an example. All right, so moving along, the next main tool is Monkey Graph. This has been there since ConnectIQ 2. You can access it through Eclipse, and a really simple tool that graphs all your fit field data. Help you find bugs there. Make sure your fit fields are set up properly, that you're logging data correctly, and that the data you actually see is the correct data you expect. So you can verify your fit fields are working completely fine before you release your app. And the new tool, Time Machine, as Jeff would say, in CIQ 3.1. You can access this while the simulator is running. Note, this is only for watch faces, so don't try and access it from a widget. I made that mistake my first time. And when you do, you get a window that looks like this. So you can set any date and time that you want. You can set the simulation speed for that's how many seconds in the watch face world happens per real-time seconds. It goes from 1 to 1,000. And then you hit start and stop, and it resets automatically back to where it was, the time that you specified, so you can just keep running over and over and over again. And this is a really fantastic tool because it lets you test all those weird time edge cases. So if you're storing, say you've got a watch face that stores daily data, like steps are, but it's your custom daily data, and you need to do a reset at midnight, you can run through a midnight instead of having to hack in a fake midnight transition and try to fake your way to test it that way. You can also test daylight savings time. So say you're relying on a day being 24 hours. Well, daylight savings time would break that because you can have a 23 or 25-hour day. And so you can go do a quick run through that, again, instead of hacking it together in code and having to rerun and make sure you hacked it together correctly. So overall, it's just a really great unit test for watch faces. So to recap, Jeff went over a couple of ways to look at your bugs and find your bugs with the printf debugging and the debugger, and went a little bit into postmortem. And then we went over the storage editor, the tools, more tools we have to help you catch your bugs before they get into the wild. So the storage editor, the web traffic viewer, the memory viewer, Monkey Graph, and Time Machine, so that hopefully you don't actually release any bugs into the wild.
But Adam, what if we do release a bug into the wild? What's going to happen next? Well, as I mentioned before, all your users are for sure 100% going to find every bug you release and give you a 1-star review, and nobody likes 1-star reviews. So we got one more thing for you, and we saved the best for last, and it was mentioned earlier in the keynote, and that is crash log reporting. New in ConnectIQ 3.1, available today apparently, you can see a list of all the crashes that happen in the field for your released products. We're going to just show you a few screenshots of it today because this is new to all of us, right? So in Eclipse, if you go ConnectIQ start crash log viewer, you're going to see a blank window. Okay, that's not so exciting. Well, we have to add in our developer credentials here so that we can see the crashes that matter to our apps. All right, so we're going to go to Manage Developers, click Add, and we get this screen right here. First, you're going to put in your developer ID, which I'll tell you what that is in a second. And if you sign all of your apps with the same developer key, you can add in your default developer key at this point. Otherwise, later on, you can set an individual key for individual apps. And I actually think you can override the default key for individual apps later. So, but what's your developer ID? Okay, well, to find your developer ID currently, just go to the store, click on one of your apps, and then look for your author name. If you click on that, you'll get a list of all of your apps, and in the URL right there, that is your developer key. So punch that in Eclipse, And I don't have slides for it because this is a brand new feature, but you're going to also select the apps that you want to get crash logs for. And ta-da, you will get something that looks like this. All right, so what's all here? Well, we got a lot of great information here. We can have a list of all the apps we've selected that we want to get crash logs for. We dedupe the apps for you, so you will only get individual crash logs, not every single instance of it. The crash logs are based on the backtrace stack, so you will get a backtrace down here. You can see how many times it has occurred and when it has occurred, the time range for that, as well as the devices it's occurring on. Well, why is this good? It saves you loads of time because instead of having to try and decipher a 1-star, this doesn't work review, and you go back and, hey, SQ testers, how come you guys didn't find this? Why did our users find this? Well, you can just look at crash log, find it immediately. The backtrace is right there, so you can immediately start using all the other tools we showed you to track down that bug and find a fix for it. This also lets you prioritize, the bugs that are happening the most. Say you get 100 crashes in your first day in your login function. Well, that's no good. So that's probably a pretty high priority issue, but maybe you get a few crashes in some super edge case that would be too hard to fix, so maybe not as important. This is a feature we know you guys are gonna love. We know you guys deserve this feature. This is the feature as an app developer I'm looking forward to using the most. It's just an awesome feature, and a lot of hard work went into this. The SDK team, our Garmin Connect team. So let's just give a round of applause for this feature to everyone who worked on that. We hope this is super helpful for you guys moving forward. Okay, so summarizing what we've gone through, we went through how to identify bugs in development, in testing, and now in the field with Crash Reporter. We went through different ways of how to investigate the cause of our bugs using all our great tools in the simulator, debugging, all that good stuff. We showed you LogMonkey, use barrels, they're actually really handy. And Adam gave us some excellent information on how to save memory in those cases where we really need to. That sums it up for us. I'm gonna go ahead and open up for questions. Yes. Am I, okay.
What would you need it for, just out of curiosity? So I'm making a web request, and I know the data is fairly static. So I'm going to cache some of the data and not make the web request every time the widget opens. So I'm just going to show hands like time machine for the other app types. All right.
So just for the just for the recording, the question was, are we going to have Time Machine on widgets? And the room says, yes, we want that. So TBD on that one. Anybody have any questions about the presentation, about debugging, any of the tools we went over, any of our memory saving? Yes?
Yeah, two different questions. How long are the crash logs maintained for? And then second question, all these new tools, will they be available in the Linux Eclipse plugin?
So the first question was, how long do we maintain crash logs? I believe to be GDPR compliant, that is 30 days. So yes, they will go away over 30 days, obviously if you keep them yourself. The second one, is it available in the... Yes, second question, is it available in the Linux plugin? I'm getting a thumbs up, yes, Linux SDK crash logs, good to go.
Why would you use Linux instead of COTS? I assumed the news were effectively COTS.
Yeah, enums are effectively const. They can be useful if you need to do the auto numbering that enums do.
But if they actually had overhead, you're saying?
Enums and const both have that overhead. Yeah. Yeah.
So then the answer is readability, I suppose.
Yeah.
Code
Yeah.
maintainability.
COTS were in mind, enums were...
Well, when I meant constant, but I meant the actual physical number does not get inlined. consts are still treated like enums are treated like consts, and consts still have the like an actual constant. Yeah. Sorry, I didn't make that clear.
Yeah, if you are using magic numbers throughout your code, which you were told not to do in college. Any other questions?
Do you know, since you've been using this tool, is there like a predominant area you're seeing? So I know the example you had obviously would have been caught if the compiler was typing. Is there a lot of that type of stuff? Or?
When you say this tool, do you mean Crash Reporter?
Yeah.
Crash Reporter is like brand new today, so nobody has used it yet.
Well, you guys have probably used it in-house. So
I haven't used it enough. You trying to say what's the most common error that people release? I do not have data on that.
like I just said, your example was one that fit under the client compiler section, right?
Right, yeah, so
The kind of errors that
you would figure, yes. So I don't have data on most common. Maybe next year we'll have a great slide about here's all the things that got caught in Garmin apps. No bugs, because I'm writing them. Okay. Anybody else? All right, well, if you think of something else, I will be around. I'll be at the event tonight. I know I'm wearing blue shirt and khakis, but I promise to be less invasive than your former favorite big box electronic retailer store. Other than that, thanks, guys. Appreciate coming.